So today we will discuss the next topic after the pneumatic control, that is hydraulic control system. So the control movement of parts or a controlled application of force is a common requirement in the industries. So these operations are performed mainly by using electrical machines or diesel, petrol, steam engines as a prime mover. The enclosed fluid, okay, that could be liquid and gases, can also be used as prime mover to provide controlled motion and force to the objects or substances. So specially designed enclosed fluid system can provide both linear as well as rotary motion. So in this topic, in this system, we are discussing about the uh, movement of fluid. That is uh, the difference between a pneumatic system which uses air. Here, hydraulic system uses fluid. So this kind of enclosed fluid-based system using pressurized incompressible liquid as transmission media are called as hydraulic systems. So the components of hydraulic system: first one, prime mover; second, pump; third, control valve; fourth, actuator. So that could be hydraulic motors or pistons; fifth, piping system; and sixth, a fluid. So next is the components of a hydraulic system. So the supporting components include, so first one is filters, second strainers, third storage tanks, fourth heat exchanger, five pressure gauge, six sensors, seven protective devices, eight control devices, nine accumulators. So discussing these topics one by one. So first one is the prime mover. So prime mover is a device which develops the mechanical power. So this power in a hydraulic system is basically used to drive the pump. So prime mover includes internal combustion engine or turbine, okay, or some other similar type of equipments or the devices. Next is hydraulic pumps. So pump is a device which converts mechanical energy to fluid energy. So hydraulic pump takes hydraulic fluid, mostly some oil, from the storage tank and delivers it to the rest of the hydraulic circuit. So the hydraulic pumps are characterized by its flow rate capacity, power consumption, drive speed, pressure delivered at the outlet, and efficiency of the pump. Then next is the control valves. So the control of mechanical outputs, so motion and force, is one of the most important functions in a hydraulic system. The proper selection of control selection ensures the desired output and safe functioning of the system. So in order to control the hydraulic outputs, different type of control valves are required. So they are like directional flow valves, directional control valves, then flow control valves, then pressure control valves. Now next is hydraulic actuators. So hydraulic actuators employ hydraulic pressure to drive an output member. So these are used where high speed and large forces are required. The fluid used in hydraulic actuator is highly incompressible. So they convert high power fluid into mechanical power. Okay, so fluid power into mechanical power. So depending on motion, they can be classified as linear actuator and rotary actuator. So linear motion and output that is obtained from linear actuators. So that could be like cylinder or piston. Then in the case of rotary actuator, we obtain a rotary motion that is similar to a motor. Next is the hydraulic fluid. So hydraulic fluid must be essentially non-compressible to be able to transmit power instantaneously from one part of the system to another. At the same time, it should lubricate the moving parts to reduce friction loss and cool the components so that the heat generated does not lead to fire hazards. So the most common liquid used in hydraulic system is petroleum oil because it is only very slightly compressible. So properties of hydraulic fluids like non-compressible, then low volatility, corrosion control, fire resistance, low toxicity, and good lubricator. Next is filters. So the hydraulic fluid is kept clean in the system with the help of filters and strainers. So it removes minute particles from the fluid which can cause blocking of the orifice of the servo valves or cause jamming of spools. Then types of hydraulic filters. Suction filter. The suction filter provides protection to the hydraulic pump from particles larger than 10 micron. Then pressure side filters. So they are located downstream from the hydraulic pump. So these filters are designed to clean the fluid as it exits the pump and protects more sensitive system components such as control valves and actuators from contaminants generating from the pump. Next is accumulators. So unlike gases, the fluids used in hydraulic system cannot be compressed and stored to cater to sudden demands of high flow rates that cannot be supplied by the pump. So an accumulator in a hydraulic system provides a means of storing these incompressible fluids under pressure created either by a spring compressed a gas. So any tendency for pressure to drop at the inlet causes the spring or the gas to force the fluid back out, supplying the demand flow rate. So the diagram here we can see a bladder accumulator and a piston accumulator. Now the applications of hydraulic systems. So first one is industrial. So the plastic processing machinery, steel making, primary metal extraction applications, automated production lines, machine tool industries, paper industries, loaders, crushers, textile machineries, R&D equipment and robotic system. Next is mobile hydraulics. So tractions, irrigation system, earth moving equipment, materials, material handling equipment, commercial vehicle, tunnel boring equipment, rail equipment, building and construction machineries, and drilling rigs. Next is automobiles. So it is used in the system like brakes, shock absorbers, steering system, windshield, lift and cleaning, etc. So marine application. So it mostly covers ocean-going vessels, fishing boats, and naval equipments. Then last is the aerospace equipment. So there are components and systems used for rudder control, landing gear, brakes, flight control and transmission, which are used in airplanes, rockets and spaceships.